Thank you for joining us this evening. You were brought into this session with your microphone and video off. If you have questions, please put them in the chat. Comments are welcome too. Megan will collect the questions and address them to Adrian after his presentation. The program will be recorded and it will be made available on the Detroit Public Library YouTube channel and through Wayne State University's website. I'm Jennifer Dye, a librarian at Detroit Public Library. We've had astronomy programs for several years. We've been very fortunate to work with a lot of the astronomy organizations nearby and with Megan at the Wayne State Planetarium. Before the upheavals of 2020, we had in-person programs, and we've been doing online astronomy programs starting in early 2021. And I'd like to introduce Megan McCullen, director of the Wayne State University Planetarium. She works with us on the Zoom program, and she has provided us a link into the community of Wayne State University faculty and alumni. Megan?
Thanks, Jennifer. We're always happy to participate and always glad. This is actually, Adrian, I think this is how I first really got connected with you, because we had a chance to chit chat before we would do shows. And so Adrian's come out to some of our community events to help out as well. So it's been a nice collaboration in multiple respects. We are currently about to start final exams at Wayne State, so we're not doing a lot of programming right now, but we will again in another week. But this Saturday is tentatively statewide astronomy night, and we're going to be out at Belle Isle Nature Center, but the weather is looking poor. So we will determine Friday at noon if we have to bump it a week until the following Saturday. But if you're in the area, I know a bunch of you are from out of state, so this doesn't apply to you, but we will be out at Belle Isle Nature Center with our telescopes. This year, the Michigan Science Center will be out there with their portable planetarium indoors, so we'll still have something. And we're also working with the Nature Center to use binoculars to do both twilight hikes and look at animals, but then binoculars are also useful for looking at the moon. So we're going to do a little bit of exploring both telescopes and binoculars this year. So it should be a lot of fun. I will put a link to it in the chat. And I think I'll leave it at that. We'll have shows going on during the summer. You just have to check ahead for it. And we should have them online in a couple more days.
Okay, thank you, Megan. Adrian Bradley is an award-winning landscape astrophotographer. He's shared his knowledge and his photographs with us several times. He will talk tonight about the equipment and methods for getting shots of the Milky Way and how to find dark skies. His methods are more for photographers who want to produce nice detailed pictures to print or share online. He recently won a first place award for one of his landscape astrophotos depicting the impact of light pollution in a Royal Astronomical Society of Canada astrophotography contest. I have his photography website here, and Adrian, please
take over.
Yes, take over. I'm sorry, I'm just fumbling for some reason.
That's okay. Thank you all for showing up. Thank you all for coming out, and I wanted to share the actual award-winning photo before I get started, because I know many of you, I've got a few of you here, and you'll go, I wonder what that picture looked like. Well, I'll start out on doing a couple things here. So let me go ahead and share my screen. And so this photo made it on a magazine cover it's called Skies Up. It's an online magazine cover, and it's a part of what I'll talk about today. Milky Way photography has become something that a lot more people, especially those who may shoot professionally, are interested in. They're interested in the night sky. However, when you see those Milky Way photos, this isn't what you normally see. That's actually Orion. This is a camera that I use really quick. Let's go through that. You can get your camera modified because space gives you images. Space gives you light that certain spectrum of light that you can't see with your eyes. Our cameras are set up to block those spectra of light that a camera sensor can pick up. But if you take that out, then suddenly it gives a pinkish color to some of these other structures in the night sky. And that's how a lot of Milky Way photographers end up getting these beautiful images. We titled this Chasing Dark Skies. These are the affiliations that I'm with. And the reason that I call it Chasing Dark Skies is because that's a key ingredient for some of the Milky Way photography you're seeing here. The away from a lot of what we call light pollution in the big cities, or even some of the townships where a lot of light is being thrown up. If you look at this image here, there's light from some distant towns being caught by the clouds here. So above it, you see some parts of this part of the Milky Way here. Out here where everybody's camped, none of that light exists, and this gets really, really bright. This is the core of the Milky Way galaxy that you see if you go online and you go Milky Way photos. It's a lot of it is northern hemisphere based, but southern hemisphere sees slightly different parts of the Milky Way. And I'll go through it real quick. The poem My Eye is on the Sky by Dr. David Levy, whom is a discoverer of comets, loves the night sky, and is a friend of mine. So let's quickly shoot through these. So the question of what is a dark sky, and the more you go, say you go to a place and you see more stars than you'd ever seen before, you'll think, okay, that's a really dark sky. There are some measurements and there are scales that are used. The Bortle scale is what it's called, that basically assigns a number from 1 to around 7 or 8 to talk about how dark the sky is. And a scale of 1, really, really dark, 7 or 8 would be in a city. And so this was taken where the scale is near 1. And these are things that people will see. And, it's the darkest place I've ever been, is often what people will say. So when places like Cherry Hill, I'm going to mention some places, some of you may have been, some not, they'll say it's dark. Their recollection of it, there's 2 reasons for it. Their recollection of it is that they saw a lot of stars in the sky, and they were also able to do a measurement, and the measurement was a solid measurement. I'll talk about how we can do measurements. Is there a way to give a fair assessment of the darkness of a site? As I've gone through and done imaging, I've learned that the darker you go, the more spoiled you are about how dark a night sky is. So someone will tell me that's really dark, and I'll say, you haven't seen the best it can be. And I haven't really seen the best I can be, because you have to go out into space to see that. That's where the sky is completely black. But let's go to the next slide and talk about some things you can look at. This is a piece of that award-winning image. Unfortunately, some of it's cut off. The Milky Way goes here. But notice how, when we talked about the effects of light pollution, how the clouds are catching all of that light, and then notice that sky and this piece of the Milky Way compared to these two images. This is in the Upper Peninsula of Michigan, and look how much brighter this looks. There's sky glow here, which is where all those colors. I did catch aurora that night, and I know that aurora has been on everyone's minds. I do have some aurora pictures. I have one that I'll show during the course of this presentation. But although this doesn't look very impressive, it just looks like a lot of really dark clouds, and you see the part of the Milky Way here. This really is impressive if you were to view it, because the Milky Way is bright enough to shine through all of these clouds. In both cases, the darker the clouds, like you see how bright these are, and it's catching light from Port Huron and even some Canadian towns over here. But over here, there's very little city light coming up. So the undersides of these clouds are dark. So if you're at a spot and you notice that the clouds are dark, you know that you're in a dark sky. Now notice how this looks on the Milky Way compared to this. This is in Michigan. It's a true to what you can see image of Lake Hudson if you stand in this particular spot, and notice how this just looks like it's blending in with the sky, whereas this has a definite dark patch to it. That's another indication. If you use the same methods to take your photos and one has more definition than the other, this is a darker sky than this. But it doesn't mean that you can't get good images in a lesser dark sky. And so I use this meter to assess the darkness of a sky and the images that you can get, the amount of work that you have to do, whether you have to take a longer exposure. And let's quickly talk about that. For those of you that are doing Milky Way images, you go somewhere dark, a wide angle lens, something between 14 millimeters to 24 millimeters, and you do something between 15 seconds, sometimes even 13 seconds to 20 seconds if you have a wider angle lens, and you can turn that ISO up because you're in this dark sky here. Now, this is a shadow. You don't have sunlight to help illuminate things. If you're in a place that there's bright lights, let's see here, we'll start with this. If you're in a place that's highly illuminated, you'll get that. But if you're not, you have to turn the ISO up in order to get some sort of image. And if you don't have a special tracker, which I do, that follows the night sky, you end up having to take two photos, which most of these are. They're composites of the ground and then the sky, and then they're combined. That's how I was able to get this detail, even though this was a really bright sky here. And you'll see these numbers go up. A tenth of a number here actually means a darker sky. The higher the number, the darker it goes. This is a dark sky preserve. For those of you here who have not been at a dark sky preserve, you're going to see a lot of stars. Notice this picture. This is that same region that I showed earlier at a really dark site. And I'll see if I have it. If I don't, it's okay. At a really dark site, that same region looks like this. So the darker the sky, this region, you notice how they've got all this light from towns of Adrian, and there's a couple other cities, Hudson, I think Hudson Lake, the city, is over here. So you can see the difference that it makes to be the darker you go. And so some places in Michigan, along Highway 25, the thumb of Michigan, you see that it's getting a little bit darker. This was the moon rising. This was actually the ISS leaving a trail as it was transiting. And here's that region of Orion again. The Milky Way let's see, we'll skip through this and then I'll show you. There are 4 parts you can see of the Milky Way. You can shoot year round. You've heard of Milky Way season. They refer to the season when the brightest part of the Milky Way here, this core, is visible, and it continues on into this region here. But in the winter, the Milky Way is still there. So you can shoot year round. The conditions may not be as comfortable in late fall or winter, but you can still shoot at the night sky and some part of the Milky Way will be there. And so as you can see, here's a direct contrast of the same area overlooking the Sable River from how it looks in winter and how it looks during the summer. This was taken in June. These were taken in December. This was taken, I want to say it was December as well. You have Orion rising here, this part of the Milky Way. That's the Andromeda Galaxy. And somewhere up there, there's another galaxy that's just off screen. This is setting. The numbers are a little bit higher, so it would appear even darker in this region. And then you go to the Thumb of Michigan, very similar. This is Albert Sleeper State Park, where you see the Milky Way coming over Orion. The comet was actually in this one. If I could zoom in, the comet was here, that green comet that we had. Here are a few images, different parts of the Milky Way. That's the core region. That's what we call the Cygnus region. These are stars of the Northern Cross. And then this was a bit of composition. This part, I'm not so sure if it wasn't aurora or just light trapped from the low level clouds that were on the horizon. As you can see, there's some bright, that's not aurora, that's the city. I think I have some actual aurora photos that will show up in the presentation, but these are very rural areas. These are actually areas where people can hunt. And this is away from most civilization, although there is a lodge and tavern here, Dark Sky Lodge and Tavern, if you want to be in this northern part of the Thumb. It's one of the areas that you can go to. And this is also in the Thumb. And here's from March 2021, similar aurora to what we just saw recently. This is a picture that I took. I was out to do Milky Way photography here, and I saw this and captured it. Very similar to the aurora that we saw just the past couple days. It's, if you can catch it, you get even more detail if you use your camera and use your same settings, your 13 to 15 second long exposure. If you have a tripod that does not have a tracker, and you up the ISO 1600, 3200. If you have a Nikon, I would go 1600 to start. I find that the ISO levels, signal to noise, tend to be a little lower on the Nikon side, but you can still get some great photos. Newer Nikon goes up to 3200, like just about everything else. Sony and Canon, even older Canon cameras can get, some pretty good signal to noise at ISO 3200. And going back, the numbers were a little different when I went back very recently to catch the rise of the Milky Way. This was this year in February. So if you're willing to go out early in the morning to do imaging for a particular part of the Milky Way, you've got about 2 months where a particular part of the Milky Way will not be visible at any given part of the night, or it comes up with the sunrise. Other than that, almost year round, any part of the Milky Way is visible. It just depends on where it is in relation to the sun. I like to use an astronomy application. I come from an astronomy background, so I use an astronomy application called Sky Safari, and I have the pro version, but you can get the regular version. Stellarium is also a good application, and it's free on a PC at least. I don't know about Macintosh, but or Apple, but you can Sky Safari works on your iOS app. Stellarium works on a PC and shows you where things are going to be in the night sky. A lot of photographers will use photo pills because they've got the Milky Way option. It'll show when the core of the Milky Way is going to be in a certain point, and allows you to decide how you want to compose based on that. I use Sky Safari, and I'll look for particular constellations in the sky. So here we go out to the western part of the state, and again, through haze, that's Venus. Here's a lighthouse. Here's Orion. Here's the winter Milky Way. Just before leaving, you can start seeing the winter Milky Way, and we're still not completely done with sunset. That color is there due to sunset. There's some glow here. We're in Lake Michigan. It would not surprise me if this glow actually came from across the lake where Chicago is, or any of the other cities across Lake Michigan. I would expect something Wisconsin, maybe from this point, because I would guess Chicago to be further down. But there are Wisconsin cities across the lake as well. So you can actually see so many miles out. You can see light from distant towns. Over the lake itself, it's pretty dark. So the Milky Way begins to appear here, and it appears once the sun fully goes down, you get this part of the Milky Way by Orion. So where the lowbrows do observation, this is called Peach Mountain. It's it's the McMath 24-inch Cassegrain telescope. You can get some pretty good images of the Milky Way here as it crosses over, if it rises and crosses over, but it does take a lot more of an exposure time. I think both of these were 2 minutes, and then processing, getting rid of some of the noise and doing things with Photoshop to pull out the structure of the Milky Way a little more. So there's more tricks that you have to play. The darker a site you go to, the less of those tricks you have to do in post-processing. You see more of the Milky Way without having to tease it out using astronomy tools or other types of tools that help get these final pictures. And then you go somewhere where the SQO reading is near 22. This is Kenton, Oklahoma. Aside from being Tornado Alley, it's a place where there's very little civilization for 50 miles or more. And if these parts of the Milky Way appear bright, it's because they are that bright. There's the zodiacal light from here. And this is where a lot of those that like to look through their telescopes, you can see all kinds of detail in galaxies. You see the spiral arms looking through telescopes, and you don't need a big telescope to see some of that detail. When you look in the night sky, it's hard to tell where the constellations begin and end, just because of how much. And then the detail you get when you image here is, to me, it's pretty astounding. And so here's that aurora picture. And this was just from going north, aiming towards the left, or towards the north. So the Big Dipper's here. I have a bigger picture of it, and I'll try and show that. All of these places, including Stargate, I've got more work to do in order to get some more images. But this place here in particular, all of these places, this is the actual dark sky preserve that's in Port, I believe it's in Port Austin. It's Port Crescent Dark Sky Preserve. And this image is also from Port Stanislac, the roadside park that overlooks all this area where Port, I forget the town, Port Huron, and then parts of Canada. And then my background image is taken in the Upper Peninsula until I got to the dark skies of Kenton, Oklahoma. This was the darkest I'd ever seen. A lot of the detail you're seeing here was visible. It was faint, but you could see this shape. You could actually see that dust lane. You might not see this part of the Milky Way, but you could see most of this naked eye. And the same was true for, if we go back, you could see a lot of this structure naked eye. This maybe not so much, you have to image it. It's fainter, but you could see a lot of it without the colors for these things. But most of it was true to what was in the eye. And here's the perfect example of it. When you look up at the night sky at this part of the Milky Way and you're in a spot that's dark, this is exactly what you see. This goes white. You don't see the reddish colors in here, but you see these regions. You see this small star cloud. Everything else, Sagittarius is over here. These are the stars of Sagittarius right here. That's actually a globular cluster, but that's the different with the DSO. You see these little patches of light here. Those are clusters too. Those are larger star clusters. You see all of that when you're in a site that's a naked eye site. And so really quick, what did I do with here?
While you're looking for that, Adrian, I'll just mention if anybody's got questions, they can put them in the chat. But I've also been posting links to places as you've mentioned them or organizations as you've mentioned them. So if you were like, what's the lowbrow astronomers? It's in the chat.
Yes.
So go ahead and look for those resources, folks.
Okay, so we have a little time here. Some of these shots you'll see again that you saw in the presentation. It's a little closer up. This is an article that I'm writing. Most of what I mentioned during the presentation, here's where I'd like to get to here. The 4 areas that you can image. If you want to go image the Milky Way, you'll hear things like the Milky Way season. They are talking about the galactic core. So they're talking about imaging this part, imaging this part of the Milky Way. And it's interesting, you see things crisscross. Sometimes it's meteors, other times it's a straight plane. And in this case, let's look close. Let's see if we can tell. That, not sure. Solid lines usually means it's a plane or a satellite. Usually you see dashes if it's a plane. So that would be a satellite. When you see lines taper, it's usually a meteor. It's like you have a bright spot here. This could just be a star that it passed through. And it starts out faint and grows. That's usually the sign that you're looking at a meteor. So we can look at closer look at some of the shots. Now let's talk about these regions. These are the regions we see in the Northern Hemisphere, which I think most of us would say we live in the Northern Hemisphere. Orion's region. So you've seen this image. Here's a little closer up. You've seen a couple versions of the image, but there's Milky Way here. And there are astrophotographers that like to catch this region. It's called the California Nebula. I saw someone was from California. Here's your nebula right here. And then it's shaped a little bit like California. And this is that star cluster you see every winter, the Pleiades. It glows like this. And this is what else is around that region in space. A lot of folks will image this and they'll ask, well, what's this? What's this gas and dust that's going on? And I'll show them this picture and they'll go, oh, it's a part of the Milky Way. And it can be enlightening to realize that this is a part of the Milky Way too, because we're accustomed to other sights. Here you see the zodiacal light combined with this, it creates an X combined with this part of the Milky Way. Now, if we were to continue looking through the ground below the horizon, that's where you would see the Magellanic Clouds in the Eta Carinae region. Those are regions that can be seen in the southern hemisphere. The Milky Way essentially looks like it kind of wraps in a big circle, but it's the part that we can see from our vantage point, where we are in the galaxy. And from this vantage point, you can see Andromeda. You're seeing a whole different galaxy. You're seeing two of them. That's another galaxy too. It's a smaller one, called the Pinwheel. And this one is the larger Andromeda galaxy that's headed for us. All of these galaxies, this is the arm from our galaxy, and you have two others. It's called the local group. There's the Magellanic Clouds, and I think there are a couple of other dwarf galaxies that have been discovered that are all part of what we call the local group. Those are the group of galaxies that are, only a mere 2 million light years away, as opposed to well over 50 million light years away. Whenever you look at the Big Dipper, just as an aside, you're looking in the direction of a particular galaxy that happens to be about 51 million light years away, just under the handle. You really don't see it with the naked eye, but in pictures sometimes you can pick it out. It's actually this dot right here. No, it's this dot. One of these two dots, I believe it's this faint dot right here, is actually a galaxy. And here's an aurora picture again. I wanted to take a picture of the Big and Little Dipper. You can barely see their stars. This is part of the galaxy is here, Perseus. There are a couple of nebula here, and there's the aurora. I'm sure it looked like this yesterday. If I were on this road in the Upper Peninsula, I'm sure I would have seen even more spectacular sight. The aurora would have covered this entire picture. This was taken in June, so that's when this part of the Dippers look like this. The Milky Way from the Perseus side looks like this. Again, as I said, we should be using this region a lot more often, because if we want to combine the Milky Way with the aurora, that's one way to do it. So it's an often overlooked region, but there's a lot going on and different galaxies. This part of the Milky Way is all that's left after the core sets. It's another bright region. We call it the Summer Triangle region because stars of the Summer Triangle are embedded. Now, most of them in the pictures I've taken, there's a set of stars. There's a constellation here that's behind the mesa, but combine this star, and then the star behind the mesa, that's the Summer Triangle. And as it sets, and this part of the Milky Way sets, the Orion part of the Milky Way rises. So here you have it. There go the parts of the Northern Cross, it's called. There's a Southern Cross, but you only see it in the Southern Hemisphere, or if you go as far down as the Florida Keys, it'll rise above the horizon. And so out here, you see all kinds of light, which could be sky glow. Sky glow, real quick definition, radiation from the sun that sits in the upper atmosphere and glows at night. The earth captures that radiation and it glows. It's not quite aurora. It does have to do with sun's radiation, similar to aurora, but rather than exciting ions and showing all the colors, it sits in the atmosphere as like a thin green or red layer, again based on the elements that have been radiated throughout daytime. And so here, the galactic core, when you talk Milky Way photography, you talk images like this. The core is made a lot larger. In the Royal Astronomical Society of Canada, I entered that image that I showed that took first place for light pollution. Well, there was a general category for just Milky Way image. And even though this did not win, it came in second. And I was proud to know that out of all of the beautiful Milky Way images, this one with Scorpius, there's Sagittarius here, the Scorpion here, and this was actually taken in a not so dark area, but a concentrated 2 minutes exposure, and I was able to get nebula here, there, and everywhere, and I was able to get this photo. It came in second, and I was plenty happy with that, just because the judges liked the detail. Now, in a different contest, this one may not even place. There's no Taj Mahal in front of it or any of the other things you can do to beautify an overall picture. But my focus has always been on the night sky itself. And that's why my images are more about the night sky. And these are the places that I took the pictures. And if you notice, a lot of them are in Kenton, Oklahoma. A lot of them are in the thumb as well. So when you're wanting to go to places, dark site finder, let's see if this will help. And then I'll open the floor to questions. Let's go. Here's a picture taken in Brockway Mountain. And yes, you saw I had a couple of similar pictures. He managed to get a couple meteors in his shot. There is a place to see here, this map. And this is an ad that we don't want. Let's go. Yeah, we do not want to. Here we go. And I'll need to see if I can click away from that. Here's the map. So what you're seeing is there's a lot more cities to the eastern part of the United States. And to the west, there aren't as many cities. Where we go to, where I went to take those photos, it's right here. Black Mesa State Park is very close. As you notice, so Kenton, Oklahoma, and you notice that there's this swath of darkness. This is where we go. It's called the Okie-Tex Star Party because it's in the panhandle of Oklahoma. Texas is below it. There's Idaho, Colorado, New Mexico. A few of these states where a lot of their observatories. And this is why, if you notice this map, let's go back in. this map shows you why, even though there are observatories over here in the eastern part, this map shows you why a lot of the observatories are out west in these mountain regions here, or, you know, higher elevation. It's just the skies end up darker. And if you go to where the big cities are, you notice that it's brighter. Now, if you look at Michigan, oops, that's a little too far. You notice that here in the thumb, and as you go north, this red and yellow gives way to green with a few spots of yellow and even some darker blue areas. This dark blue area right here is where that lighthouse is, which is why I like to go there and image. But Lake Hudson sits in a green area, which is it's the beginning of having decent enough skies to see a lot of stars. There's a Detroit area, and this is why you don't see it in the Detroit area. It casts a real big glow. You can be up here, look to the south, even in this area, you can look to the south by southwest and see some of this light glow. And this is a good 2 to 3 hours away. You drive from here up the thumb, you can still see the light glow. So the further north you go, so there's a park here, there's the headlands over here, which is dark, but some of those places in the Upper Peninsula where I took photos were over here, where it's even darker than in the Dark Sky Park. There's Sault Ste. Marie right there. Paradise is over here. And that's why, and then over the lakes, of course, it's even darker. And that's why I like to shoot north in Michigan. There are some places in Ohio. This is a pretty good place in Ohio, well, because it's Lake Erie. And then you've got Cherry Springs State Park. You see how dark it is. It's been made into a preserve, and it's one of the few places on the eastern side of the states where it gets dark enough to see, you know, as if you were in the middle of a lake. This area is forest land, so it's really hard to see the sky when you're tromping through forest land. But the El Sable River is over there, and that's where I took some of my photos along the El Sable River. So that is going to do it for my presentation. Hopefully there was some good information there. I'm going to go ahead and stop sharing the screen, and I will open the floor to questions, anything that I may not have covered, or any other type of question you may have about, you know, if you want more information about the equipment I use, I can share more info about that.
So thank you. This was awesome. The first question we have in the chat is from Mark Smith, who incidentally, I don't know if you know this, Mark, there is a Mark Smith Planetarium in Macon, Georgia. So I feel like you should visit. He wanted to know if you could touch on how you handle post-processing of your images.
Yes, I see. And I see your question now too, Mark. What I do is use a suite of programs. I'll just mention them. Lightroom Classic, I import in a Lightroom Classic, and then I'll edit the let's see, I would love to show that, but it may just take too long because I think I have a bit of a memory problem running on the computer. So import in Lightroom Classic and edit white balance, especially if I'm using my modified camera. I created a click that I could do. I can click on something to edit the white balance so that it matches what we naturally see, the colors that we see, and adds the color for like the HA regions. I'll use some scripts that I downloaded and embedded plugins for Photoshop to get the night sky looking, basically pull a little bit more of the Milky Way out and shrink the stars a bit. It's a look that I like without doing too much to it. I don't want the sky to look completely different based on where I am. If the Milky Way is faint, I want the Milky Way to be there, but I want it fainter than if I'm shooting in a darker area, the Milky Way will be brighter. So I'll do that. I may touch it up a bit. If I'm doing a composite, I'll definitely use Photoshop to layer the still shot for the ground, the sharper shot, and I'll layer it with the sky. And then after that, flatten the image, run those astronomy tools to pull the Milky Way out a little bit more. And what it does is it brightens the area of the picture without it doesn't touch the ground, or the landscape that I may have underneath the image, but it'll brighten some of the areas of the night sky that I've taken. And then after that, I export it. And let's see, I was looking to see if I had kind of what I call kind of a evolution of how I do it with this image. So you've got a panorama. So this was at Albert Sleeper, standing on the ice, and someone was down here, but they never came this way. This was a panel of 3 30-second shots being tracked, and in order to get the dust lanes and the part of the Milky Way from here, Cassiopeia, all the way to, you have Orion, Taurus. This is a part of Canis Major. In order to do that, the tools I used were Photoshop. Once we stitched this together, Lightroom stitched it together into a panorama. Photoshop brought out some of this detail by using a plugin in Photoshop for astronomy tools, and it's called Enhanced DSO and Reduced Stars. And then after bringing it back in Lightroom, I used masking to bring up, the detail here and separate it. There's tools to mask, which are really good now for, splitting the sky and the ground. And I use those a lot. Once I'm done, I'll export the photo and share it online. So hopefully that answers some of the question mark. It's been a work in progress. It's let's see, and this may or may not. I have the Lightroom Classic not responding. That's a memory issue. I'm just going to close it. So
I did put a link to that in the chat, so if people want to look it
yeah.
up. Neil asked how you avoid star trails when you're using long exposures.
That is the tracker. So I think I have it. I'm going to go off screen briefly, go get it, and show you the little tracker unit. So hang on for a second. While I go get it.
I was like, oh, we'll have a nice view of his Milky Way, but then his chair popped up. Maybe he can do a new series of photos.
Okay, so while I'm putting my ears back on, this is the tracker. It's just, there's a couple of different tracking units. The reason you want these is because you want to follow the night sky. And so you put it on your tripod. I have a wedge that also comes with it. This particular one has its own wedge. I'll go get so this is here's a tripod with the wedge. This angles itself based on your latitude. So I think I can still use it to do that. So it angles, and you put your tracker on it. So this is one of a few different models you can use. I use a different wedge because it's a little more robust, but this is, so you put that on the tripod and now you can track. This rotates your camera so that it follows the night sky. Of course, what you have to do if you want your landscape, so I can go for 2 minutes, but if you want your landscape to look good, you're going to have to stop the tracker and then take a separate 2-minute exposure, or if you want to do a different level of exposure, you want to use that, you want to do that, and then you're going to have to combine the photos. You can go for 30 seconds with the tracker running and not have to combine photos, because your foreground will stay reasonably sharp because it doesn't move enough to change your foreground. And then you can, if you go for 30 seconds, but the longer, we follow an astrophotography I guess rule of thumb is the longer you image, the more detail you get. And so there can be a difference between stacking a lot of 30-second exposures versus taking one long 2-minute exposure. The image that almost won was a 2-minute exposure, one for the ground and one for the sky. So that's how I do it. I use a sky tracker, it's called, and so it follows the rotation of the Earth. And that way it you get those, like this image, I had used a tracker like this in behind me, and it was tracking for a minute, so all the stars stay relatively round. So hopefully that helps.
Awesome, thank you. Deborah asked, how long did it take you to learn how to take these photos? And I was going to ask something similar.
You all can't, I can't hear you all because I forgot to put.
Oh, you got to put your ears in.
But I do see the question you're probably reading, Megan, which is, how long did it take me to learn how to take these photos? See, I can, without hearing, you have to resort to whatever.
Good
So
skill.
Deborah, this is going on year 7 or 8. I think I started in 2017. So that may, at 2017, trying to take photos without a tracker somewhere around here. And I probably won't be able to find it now, but somewhere around here, I have like a photo that I took with an old Canon 30D. It was 40 seconds. I barely got the Milky Way. It's been a work in progress. And if you count backwards from 23 to 17, that's how many years I've been doing it. During the pandemic in 2020, I was out a lot. And that's, almost once a week going out, because that was my way. Rather than distancing or sheltering inside, I sheltered in the sparse areas in northern Michigan. I felt that was a great way to pass the time, and it worked out because I was able to learn quite a few things. I've also I learned from a couple of YouTube videos, but Alan Dyer did a presentation for the Royal Astronomical Society of Canada, and that's where I learned mostly about doing compositions, separate exposures for different photos. I will look for one photo where I did a slightly different exposure because I wanted to catch a reflection of the stars. And if I did a longer exposure for the ground, it streaked it created streaks in the water. The sky was perfectly starry, but it created streaks in the water. So I used some slightly different settings to match the ground. And what I found is that for however many seconds and whatever your ISO setting is, you get roughly the same exposure if you take your ISO by half. I'm trying to remember what I did is there's some math I figured out that seemed to work really well. So if I went 2 minutes at a certain ISO, say 800, and I wanted to shoot for 30 seconds, so that's like for every 30 seconds, that's like a quarter of the time. So I had to multiply the ISO by that same number, that number 4, in order to end up with the same exposure. One day I'll write that down after I play with it some more. But what that resulted in, if I can find it, here we go. Let's see if this. Yeah, this is the image here. We'll share screen one more time. And so here's an image where I did a composite and I needed the stars to be as round as possible and the planet Venus here, so that the reflection of the stars that was in the water would match the reflection of the stars in the sky. And in order to do that, I had to do a different exposure for when I captured the detail on the ground here, as opposed to the 2-minute exposure to get some of the Milky Way here. Again, this is Lake Hudson. It's a dark sky park, but again, you see all of the light escaping into the sky here. So 2 minutes for this, 30 seconds for the lake. And then there is a noise reduction tool that I use to get rid of some of the noise. Here I can zoom in. There's California Nebula again. There's left of the Pleiades, and there's Venus. And because I wanted this to show starlight, I had to play around with the exposure and ISO and still get all of this. So this was shot 30 seconds, 3200 ISO. This was shot at 800 ISO, 2 minutes, and they blend. So those are some of the little tips and tricks that you learn as you continue to create your images. My goal is, and thank you, Deborah, writing a book. I'm working on it. Ed, you asked if I captured the 5 planets recently. I've got something for you. It'll be worth taking a couple extra minutes to find this, and I'm going to look for it. What I'll do is I'll go to I'll just go to the images because it'll be quicker if I go to dusk till dawn. And I'll share the screen one more time. I did not catch the 5 planets this year, but as you recall, they lined up. Let's see, was this through a telescope? I'm going to respond. Send it. Let's see. Share screen one more time. Sometimes I'll do a little bit of astrophotography. And these are all the images. You can get there through the portfolio site. And there's a link to this album, From Dusk Till Dawn. feel free to check it out. I'm just going to shoot through it really quickly because one of the images that I took was of the planetary lineup back in 2022. And that wasn't it. I was in Vegas and I still had to shoot the lunar eclipse. It's over South Point. And here's another, you've seen that one. I do moon shots too. Sometimes you aim your camera at the moon. And here we go with the planetary lineup images. This Jupiter and Saturn show up here, and this is the Milky Way. And then in the very next photo, here is the lineup that we had in June 21. Very similar lineup to what we had this year. And Mercury, if I can, oops. I think I can zoom in. You can barely see Mercury. You may not be able to see it. It's this dot right here. That's Mercury, Venus, and I brightened up all of them. The last quarter, Saturn. Sunrise would be somewhere between 30 minutes from this point of time. That's Lake Huron. As the sun is rising east. There's a beach area down here that you can actually get to. I chose to stay up here so that I could get this view. So yeah, that is my contribution to the planetary lineup. And yes, it is, Ed. Mercury is definitely a challenge. I had to look at my image and look for that faint dot in order to know that I had Mercury to happen to be in the belt of Venus. Once I saw it, I brightened it so that it would show up a little better in the picture. I brightened all of them so that those dots would show up. And this unintentionally, a bright star this was like one of the last stars that was visible as the sun was coming up. Yeah, maybe this one here too. I see something here. But so yeah, that pretty sure we'll have another planetary lineup, and I may give it another shot. Depends on what's going on with the moon and getting the moon composed into this shot, because the actual image, you have a really bright moon. You can't even tell what phase it's in. So you have to do a composite in order to get the moon to look any decent. And this was a panorama. I believe I stitched together just 2 or 3 shots. I forget the number. But I stitched it together. You all aren't seeing it anymore because I stopped sharing, but I shared the image that I shared. It was a panorama. So any other questions?
I think you got all of them that were in there. I was going to ask you really quickly, have you noticed more problems with is there increased satellite showing up in your images in the past couple years, or is that not an issue?
Well,
Freaks and-
I'll share. I won't have to, but there's always meteors, satellites that show up. I haven't really seen a big issue with the satellites. There are the satellite trains that show up early evening or prior to sunrise, but after that, it's actually planes that can cause even more of a problem with images. So there's all sorts of things. When you're shooting this far out, the satellites aren't your only issue. Everything crosses your field of view. Again, planes, meteors, satellites. I think those are the main 3 things that will streak across at any given time. With meteors, it tends to be a little more accepted just because they're a part of the sky there isn't much you can do about them. But take another photo and just hope that they're not a part of that next photo.
So when you're looking for a dark sky, it probably isn't a bad idea to also look at the different flight paths in the area to see, like, oh,
If
it's
you
dark.
can, otherwise, images with flight paths in them are sometimes inevitable. I do have a lot of images that didn't contain any planes. What you can do, the frequency at which planes will fly by, there'll be a group of them, and then they'll stop for a little bit. And
Okay.
as long as you have clear skies, that's kind of when you want to image. Because they aren't flying by all the time. Satellites, I think you have less of an issue with satellites when you're shooting this wide angle. Bright satellites and things like the ISS will show up. And then you have your occasional meteor, which again, the meteors are a little less of a concern just because they're cool random events and and a lot of these don't take much away from the photos. I think there's one that the editor-in-chief of Astronomy magazine, David Eicher, actually posted, and it included the meteors. I actually had this happen where someone was shooting fireworks unbeknownst to me behind here and interrupted an image. So all sorts of things can interrupt your photo. You just take another one. There's the finished photo. They were done. So, and you can see there's I think a meteor here and a couple satellites. Depending on how long an exposure, they may not detract from your image as much. And if you do stacking, which is a method that you can do, you sometimes get rid of those. You get rid of those meteors. I'm looking for the one that I stacked, but I didn't. Even this one, this is a perfect example of an image I wouldn't redo. There's a plane coming through it, but the image carries, it's the reenactment of when I first tried to see the Milky Way on my own, and I went to a rural area, this very cornfield, and saw faintly, even in this image, as I was taking the image, I was able to see some parts of this Milky Way faintly. If you go somewhere that's really dark, everything that you see in this image, you see naked eye. So it's a huge difference, but I was just happy to see a little bit of steam coming out of the teapot. And of course, when you're taking a photo, and I took 2 minutes again for the sky, a plane happened to come by during that exposure, there you see that there's a lot more there. So
That's a really cool photo. I like the story with that.
yeah, this one I'd stopped sharing and I'll share it again. A good thing I know how to share a screen. Aurora, they got married. Look, they got meteors coming through, and they got married at Castle Farms, and Aurora flared up as we were finishing up. So we took this photo. I did the best I could to composite them into, they stood there while I took like a quick photo, and then they moved them out of the frame without moving the camera. I took a longer exposure to capture some of this aurora that was going on behind them. So settings that you use to do night sky photography, you sometimes use for aurora capture as well. The Milky Way would have run through here, and I think I actually did try and capture some Milky Way photos, but you can see here just other images that I took while I was there. There's actually a Milky Way image that I tried to take, didn't come out so well. And so yeah, you'll be able to see all those images and comment. Yeah, if you once you get there through those sites that have been posted. So there you go.
Thank you, Adrian.
You're welcome.
Informative and beautiful as always.
Thank you. It's something I got to get back out there. Again, Milky Way is rising. It is now April, and in May, the Milky Way will rise. It won't take as long for it to rise after sundown. Orion will start after May. Orion goes. It'll be gone for 2 months, too close to the sun to see it. But then in August, you can see Orion just before sunrise. So everything rotates, comes around. So if you miss it one year, you try it again the following year. And the picture, we're looking at a picture of a star party that we were doing. One of our late astronomers. That's how I got my start, just taking pictures of just taking any picture, whether it was cloudy. This was the reason I got into it, was because there was only so much you could do with telescopes. There was only so much you could do with deep sky imaging if it was cloudy. But nightscapes, you can do almost any time. And you know, whether it's just crescent moon, or you want to try and do some Milky Way photography, or if you're even at the Golden Gate Bridge, you can still pick off a few stars here and there. So yep, it's just a matter of getting out there and seeing what you can get. So with that, we'll leave it. But look for some comet pictures in that gallery as well, when Comet Neowise was here. And I may have a couple of small green comet images. And the next big comet that comes through, I'll try and capture that one.
Awesome.
Thank you, Adrian.
There you go.
I encourage everyone to go to the portfolio. We
Yes.
try to have these programs every fourth Tuesday. We're still setting up next month's. We're having some troubles with, well, our marketing department is making some improvements, which means that I can't do as much with Eventbrite as I had been. If you want to be added to my email list, I've just put my my email address in here. We see, I guess that was my point there. You are welcome to. I don't spam people. A couple of people who are attending tonight can attest to that. I don't send you random messages. The YouTube channel, the special channel for the astronomy programs, is here. It will take a couple of weeks before our marketing department gets this up. But I hope you will join us again. And thank you, Adrian. Thank you, Megan.
Yes,
Really
thank you
appreciate
both.
it. And thank you, everyone, for coming.
Bye.
Bye. Good night. Have fun photographing, Adrian.